So the remainder and factor theorems, all of this is from Algebra 2, so that's bomb.com. If you remember it, this should be a nice, easy lesson. If you don't remember it, that's fine, because I assumed you don't remember, because people last year didn't. So 2.3, remainder and factor theorems. So consider this polynomial function, f of x, blah, blah, blah. Here's a polynomial function. So you know that if you know this function has a 0 at, let's say, x equals 3, if it has a 0 there, that means that, okay, well, let's see. If you subtract 3 on both sides, that means x minus 3 has to be a factor. Because, right, if you set each factor equal to 0, right, when we're solving, we always set each factor equal to 0. Well, if our factor is equal to 0, if that's where our x-intercept is, that means it has to be a factor. It's kind of a backwards way of saying it, but that's like the big, big star key of the day. Okay, so if x minus 3 is a factor, that means you know that there has to be a second degree polynomial that when you multiply this quadratic by x minus 3, you'll get 6x cubed minus 25 squared plus 18x minus 9, right? So if I can divide this function by x minus 3, it should go evenly, and I should get a quadratic as the answer. That's all this is saying. Cool. And if I try to take x minus 3 and I divide the polynomial by it and it doesn't go evenly, I'll have a remainder. Okay. So quick side note, hopefully you remember how to do long division, but fear not, because we're about to go through it. If I take 100 and I divide by 7, I want to know how many times can 7 go into, let me pick a different number. How about 123? Well, I cover the 2 and the 3. 7 can't go into 1. How many times can 7 go into 12?
1.
1 time. And then, so I divided 12. Right? I took 12 and divide by 7. Okay, it can go evenly 1 time. And then, so I take 1 and I multiply it by 7 and I write it underneath. Then I draw the line, change the sign, right? So I'm subtracting 7 from 12. And then I see, oh, I get 5, bring down the 3. How many times can 7 go into 53? So I'm dividing now, right? 53 divided by 7, 7. And then I'm going to multiply, right? That 7 by 7, and I get 49. Draw the line, change the sign, and I get 4, remainder. So there's 2 ways we write this. So I could say remainder 4, or I could say, 17 and 4 over 7, because 7 is what I was dividing by. Yeah, we're okay? Okay, cool. So just we're trying to remind you the order that we do long division. So no surprise, now we're going to do polynomial division. Woo, okay. So all this means is if you take a polynomial and you're dividing by a binomial, or what does it say here? Blah, blah, blah. Another polynomial that has a lesser degree, you will get the quotient plus potentially a remainder. Okay, whatever. That's a lot to say. One special thing I want you to note is if I have something like x to the 4th plus x squared plus 2, and I'm setting up a long division problem, I'm just going to tell you right now, you must include missing terms as 0. You must include missing terms as 0. So for instance, we're missing the x to the 3rd term. So if I was trying to do long division here, let's say I was trying to divide by like x minus 1, I would write x minus 1 here, and when I'm writing the dividend, right, because that's the thing that we're dividing, I would write it as x to the 4th plus 0x to the 3rd plus x squared plus 2. And I put a 0 coefficient because technically anything times 0 is 0. And that makes sense. I put a coefficient of 0 because I don't have an x to the 3rd term. Okay, just trying to set it up because you always want to go in order and take into account all of your exponents. Cool. I probably should have told you about this after we did the first problem. I'm sorry. I just want to make sure I told you about it because it's important. You have to do this for synthetic and long division. So, long division. Use long division to factor completely given one of its factors. Okay, so I want to take this function, divide by x minus 3, and then I'll find an answer, right? I should have something that's a quadratic, but the directions say factor completely, so you have to like continue to factor it out after we're done. So just a reminder about the directions. Side note, while I'm talking about directions, I made your guys' quiz for next week. What? On Thursday? Wednesday? On Wednesday you can see it. Yeah. Funny one. Okay, so number 1 on your practice quiz, it's like graph analyze the function. All I did was change what you're graphing. Just change the function. Number 2, solve the following equation. There's one just like this. I just changed the numbers, but it's similar. I might like switch the order of the problems, but like wording wise, it's the same. Number 3, leading term test. This is exactly how I like ask you. The only difference is I'm gonna change the function. Otherwise, same wording. Number 4, divide blah 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 by x minus 1 using synthetic division. So I change this a little bit and I say divide, like show it's a factor using synthetic division. Something similar. I mean, we're gonna go over that problem example today. And then use synthetic substitution. All I do is like change the number in the function. So it's 5 problems, just like the actual practice quiz. So it's just a practice quiz online, and since it's a no calculator quiz, I made them very reasonable. It's like 3rd to 5th grade level multiplication and addition subtraction. Like I feel like you don't even need to like write it on paper to show the addition subtraction. So it's definitely easier than the one I gave kids last year. Okay, back to long division. So the steps for long division, the first step that you have to do is divide. All right, so remember how we divided earlier, and then we have to multiply, right? AKA, you're gonna, since we have a binomial here, you have to distribute. It's not just one term. Then you draw the line and change sign. And then number 4, you have to combine. I messed up. I should have brought my stereo and like had some like jazz playing while I sing this to you, because it kind of has like a rhythm to it, you know, like those poetry slams, right? Divide, multiply, draw the line, change the sign, combine. It's fine, whatever. That's the order. Thank you. No, it snaps. I actually went to a poetry slam one time in college and I performed.
Really?
But I was actually into it. I wasn't like joking around like I just was.
Did you write the poem?
Yeah.
Yeah.
No, I'm actually, I don't know. People assume I just do math. What's his name? Michael McLaren, right? His name? Theater guy? McLean. Yeah, I was working yesterday and he said something. Oh, someone was asking me like, oh, you know how to knit? I was like, yeah, I knit my sister's scarf for Christmas. And then they like kept asking me questions. When I grew up, I learned how to play saxophone, clarinet, and trumpet. Like, I did theater, did speech and debate. Yeah. So, yep. Let's keep going. I didn't mean to go off. Okay, well, I'm not going to be here at school tomorrow. Don't try to find me. All right, let's do this.
We don't have class tomorrow.
I know. Just don't try to find me. I don't care.
Well, now we know where you live.
No, you don't. Cadoga Park's a large area. What are you gonna knock on the windows? Legit, like a month ago, I thought a homeless guy was knocking on my window, and I almost peed my pants. I was terrified because there was knocking on my window, and I was hyperventilating. I go over to the other part of my blinds, and I look out. It's a bird tapping on my window. Oh my god. Okay.
Do you live alone?
That's a personal question.
Scary.
I do.
If
With my cat.
Your cat?
Yeah.
Like if someone was with you and there's like a homeless person beside you, you'd feel better. But like if you're alone with a homeless
Yeah,
person,
but honestly, if I have a significant other I'm living with, I'll probably be the one who has to be the security. There's too many soft guys. Okay, let's go. Okay, let's really far off now. I'm sorry, Frankie. Okay. This is the person I'm making the screencast for. You know, I'm just gonna like secretly, privately upload and only send it to him and no one else can hear it. Okay. So talked about a lot of things just now. Okay. Okay, let's do this. Okay, step 1, divide. It's not my day. Okay, divide.
Can you like cut it out?
I don't know when I was talking about it. Like I don't know how far back to go. Wow. Okay, first step, divide. So I'm wanting to know x times what is equal to 6x cubed. Oh, 6x squared. And to be super, when you do long division, be organized. You know, have all of the squared in a row, in a line, all the x's in a column, all the numbers in a column. Do you see what I'm doing? Like vertical columns. Be organized, that way you don't mess up and miss like a coefficient. It's very easy. Okay, step 2, multiply, aka distribute. So I'm going to take 6x squared times x minus 3. So you get 6x cubed minus 18x squared. Third step, draw the line, change the sign, then you must combine. Okay, so negative 25 plus 18 is negative 7x. Because subtracting a negative, adding a positive. Because you draw the line and change the sign of everything, because guarantee people miss. If I only wrote the minus sign over here, people would subtract 18x squared instead of adding it.
I'm confused.
What?
Since you made one negative, you have to make the other positive.
Well, I'm subtracting both of them. And the second one, subtracting a negative 18, same as adding up 18.
It's like you owe $25, and then you also owe 18 to add.
But wouldn't you analyze change the sign and make the 18 negative?
No, because it was a minus 18. If I'm
minus.
subtracting a negative, the same thing as adding a positive. Bring the 18 down. Okay, so I'm not going to show the distributing every time, but this time I think it's fruitful. So 18x divided by x equals 18. No, wait, what? I'm sorry. 7x squared. Negative 7x squared over x is negative 7x. Distribute negative 7x times x minus 3. Alright, so that is negative 7x squared. Negative 3 times negative 7x is plus 21x. Draw the line, and then I have to change the sign of both of these. So now it's a minus 21. So it's a negative 3x. Bring down the 9. Then I must start again. Ready? Another round of divide, multiply, draw a line, change sign, combine. Woo, woo. Okay. Divide. Negative 3. Distribute. Negative 3x. Oops, I forgot to show. Negative 3x plus 9. Draw the line, change the sign, and we get 0. That makes sense, right? Because we said it's a factor. So if it's a factor, it should evenly go in, and we shouldn't have a remainder. Sweet. We're almost done. We're close. We're almost done. So far, the factors I have are x minus 3 and 6x squared minus 7x minus 3. But we have to factor completely. Factor completely. So, little challenge. Got to factor this portion because it's a quadratic. If it's not factorable, we can say it's prime and leave it, right? So prime means that you can't rewrite it in terms of like polynomial factors. We don't want any fractions or decimals. But let's see if it is prime. So coefficients other than 1, I'll take you through this first one like step by step in case you don't remember from Algebra 2. Am I okay to scroll over? Okay. I want to make sure I'm not like rushing you to write. No hand cramps allowed. Okay, so 6x squared minus 7x minus 3. So these are like ax squared when a is greater than 1, right? The coefficient in front of x squared. This is called the case-if method. I don't know. That's what I call it. This is how you factor with coefficients other than 1. So you take the 6, multiply it times your c, so you have x squared minus 7x minus 18. Did I copy the, it is negative? Oh, wait, okay, cool. I keep missing signs today, the plus and minus, so like try to point out if I miss it. All right, what multiplies to negative 18 adds negative 7? Well, that's just going to be negative 9 and 2. And this is where half the people who had a problem like this on their final, I think it was my intermediate, half the people forgot this next step. You have to take the coefficient and put it back in. So rewrite this as 6x minus 9 and 6x plus 2. And the last step is to simplify the factors. So for instance, 6 and 9 both have a factor of 3 in them. 6 and 2 both have a factor of 2. So I can simplify it by writing 2x minus 3 and 3x plus 1. So bring that back up here. And the fully factored form would be x minus 3 times 2x minus 3 times 3x plus 1. This would be the answer. Use long division to factor completely given one of its factors. So we found the factor, we divided out to find the quotient, right? And then we took the quotient and factored it. Lots of work. Let me just be clear what each one of these is. So the thing that we found at the end is called the quotient. The item that we're dividing by is called the divisor. And this guy right here, the thing that we are dividing, is the dividend. All right, questions about this so far? Wunderbar. So we're going to keep doing long division. Notice when I went over your quiz, I said synthetic substitution. I never mentioned long division, so that's not on your quiz. You're welcome. But you will do it in your homework. Now the key to knowing when to use long division versus synthetic, you only can use synthetic division when you have a linear divisor. So you can't be dividing by a quadratic and use synthetic. You can use long division. You always can use long division, it's all good. But it tends to be long. That's why it's called long division. It's horrible, it takes so much time. So notice this one, we have two problems. I have this function, and I want to know if 2x minus 5 is a factor, and I want to know if x minus 3 is a factor. All right, so that's why I split it into two parts. We're going to do it twice. Okay, do you guys feel confident enough? You want to try the first one yourself? Yeah? Yes, long division. We're still doing long division. So I want you to try the first one yourself. I'm going to show it on the board just to make sure you're correct. But go ahead, give it a shot. Start with the 2x minus 5. There are two parts here. That's why I split this into half. I'm going to do the first factor on the left, and you want to fully factor it out. Mistake. Oh, this was a positive, so it should be negative. Oh, because it's negative 5, my bad. So negative. If you're done, you can check your work on the board. So we're checking if these are a factor. It goes evenly, so it's definitely a factor. So see if you can fully finish the problem by factoring it out. So if you're done with this one, you can try the other side. So because we found a remainder of 0 on the left side, we know it goes evenly, so I can actually fully factor it. If I have a remainder, it doesn't go evenly and it won't be a factor. For the right side, so you write it as a quotient. So for instance, if I had a number right here, I would say plus, let's say the number is 5, right? I would write it as 5 over 2x minus 5. If this was a 5 instead. So it would go right there. And then I wouldn't be able to factor. I would just box that and that'd be it. Do we need the left side notes up anymore? Sorry, I'll make it a little smaller, move it over. Yeah. I'll start on the right side. Since you've done it before, I kind of want you guys to practice it out. Because if you practice in class and you feel good about it, I think you should be able to do the homework pretty well on your own. It should be a good chapter for your grade and your math competence. Okay, so if you're done with this, I want to make sure we understand when we can simplify and when we can't. So we had to write, since we had a remainder, we had to write it as 63 over x minus 3. So this is going to be wrong, and I'm going to ask you, why is what I'm about to do wrong? Okay, can I scroll up and zoom in a little bit? That'll help. So can I just cross this out, 21, and here's 1, and I'm good, right? So I can write this as 21 over x minus 1. Why is this wrong? Ariella?
Because the bottom is a function, so it's all together. So you have to divide by everything.
Exactly. Yeah, it's like there's parentheses around the bottom. You have to do x minus 3 before you can take 63 and divide by it. Like you have to take this before you can do the division. Okay, so this is a common error I'm seeing among the pre-calculus and intermediate students. If you have a function, right, this bottom is a function, you can't just cancel out part of it. It has to be from every single one. If this was like 6x minus 3, you could take every single term and divide by 3, but it's not. Okay, cool. If you haven't already, you can try example 2. Did we all try example 2 already? No? Okay. So I'll go through it. I want you to try it yourself. I'll put the answer on the board though. Once again, we have a remainder, so I can write it as 3x squared minus x plus 4 plus 10 over 2x minus 1. How do I know it's plus 10 over 2x minus 1 and not minus? How do I know that? Anyone want to take a gamble? How do I know that this is a plus right here? I know it's plus this and not minus 10 over 2x minus 1.
It's the rest of the problem. It's not less than it. It's a little bit more on the.
Because remainder is positive, right? I'm not trying to trick you. I'm just trying to make sure we're clear. Because I have a remainder, if this was a negative 10, then I would be minusing the quotient. Then I'd be minusing the 10 over 2x minus 1. It's because I got a positive remainder, that's why I'm going to be adding it, okay? Just want to make sure we are clear. Not really trying to confuse you yet. Okay. So this was the long part of the lesson. Does anyone need me to keep it up? All right. So it's the full solutions. I uploaded G period solutions during bonus, so they're already up. Synthetic division. This is way better than long division in my opinion. So it's a shortcut for dividing a polynomial by a factor of the form x minus c. So let's say so this example, I'm dividing by x minus 3. So the first thing you do is you write the coefficients of the dividend in standard form. So I have 6, negative 25, 18, and 9, and so that's what I write here. And once again, if you have a missing term, you have to put a 0. So what I mean by that is if I had something like x to the 5th minus x to the 3rd plus x plus 2, you would have to write it as 1, 0, negative 1, 0, 1, and 2 as the coefficients, because we don't have an x to the 4th term. We don't have an x squared term. You have to have zeros as your placeholder. Okay, I know this. They told you this last year. Very important. This is the trick of synthetic that I can ask you. That's really, you have to know it. I'm not going to say, hey, watch out, except right now I'm telling you, hinty hint. I'm going to try to trick you. This is the only way I can trick you, is make there be missing parts. I don't know, put a star. Okay, you got to put 0 where there are missing, where there's a gap in your exponents. Okay, then you write you set x minus c equal to 0. So since I'm dividing by 3, since I'm dividing by x minus 3, you set this equal to 0, and you see, oh, okay, x equals 3. That's what you put here. It's always the opposite sign of what is in your factor. Little hinty hint, what if I'm not just dividing by a x minus 3? What if it's like 2x minus 3? Okay, well, you set it equal to 0, and you'll see, oh, you have to have 3 over 2. So you could have a fraction there as well. That's something that's doable. Okay, so you put that there. You bring the first down, multiply. Write it here, add, multiply, add these, multiply, add them. If you get a remainder of 0, that means, hey, x minus 3 was a factor. We're solid. Okay, let's do this one. So if I set x minus 3 equal to 0, I see the number I should put in is 3. So I put 3 here, draw my bar, 5, 4, 3, 2, 1, and technically this is, 8 times x is 0. Well, x is 0 is just 1, so making sure I don't have any missing parts. I could easily give you a problem where I don't give you the constant and you have to put 0 at the end? I don't know. Maybe I'll have a missing 3. Who knows? That's really the only way I can trick you, because synthetic's very straightforward. 2, -4, -3, -6, -5, and -8. Bring the first one down. Then you multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Uh-oh, we have a remainder. The remainder is always the very last one. The remainder is always the last one. And then it goes in order. Since we had an x to the 5th, right? We had an x to the 5th in our quotient. We will start with x to the 4th. It's always one less than what you divided. So I would say 2x to the 4th plus 2x to the 3rd plus 3x squared plus 3x plus 4 plus 4 over x minus 3. And then that is your answer. If you haven't already, I want you to try B. I'll leave this up for another 10 seconds or so, but I want you to try B. So this one, this is like great. This is about the level of the one I put on your quiz. This is nice math. Look at that math. You can add those problems, right? The hardest one was -5 plus 9, or maybe -8 plus 12. So try out B if you haven't already. So imagine how long this would have took us if we did long division. Look at that, synthetic, so fast, amazing. So I'm going to rewrite it. Since we had an x to the 4th term, we'll start with x to the 3rd. Was this too fast? Are we okay?
So why is it 1/4?
So if you take, so to solve, subtract 1 on both sides, 4x equals -1, and divide by 4, x equals -1/4. And so that's what you put in right here. I may. Come on, I just told you. I literally, right before B, I said, hey, A is the level of what I ask you. Okay. I wanted there to be like, I probably made it a little too easy, but I don't want you to miss the points because computation, because you forget like 4th grade math.
Oh, that's so nice of you.
Because I'm trying to test you on methods, not like addition. Like, come on.
Yeah, there's so many teachers that like did that.
I know. I'm trying to raise your math confidence because, I don't want you to hate math, right? I want you to be like neutral, right? Or like it, whatever. All I'm asking is neutral. Just don't hate it. Just don't hate it. That's fine. Okay, last page. Wonderful, because this doesn't take too long at all. The remainder and factor theorem. Sorry, do you need to go back up? Good? Yeah, okay. B, there's definitely going to be some problems on your homework, just like B. Maybe I'll throw a harder problem like that on your test. But quizzy quiz, like I said, this should be a good chapter for you. All right, raise your confidence, raise your grade. Perfect. Remainder and factor theorems. Okay, so think about it. If I wanted to know if x minus 3 is one of the factors of this whole polynomial in part A, like, is it? How do we know? Well, I divided it, right? And if it was a factor, it should go evenly, meaning the remainder would be 0. So this is a quick way to see if this binomial is a factor. Just do synthetic. If you get a remainder of 0, you're solid. Okay. So think about it. If it goes evenly and the remainder is 0, if it goes evenly, that means that factor is actually one of your solutions. Well, solution is the same word as x-intercept. Yeah? Sticking with me so far? Okay. So all of our factors are where our x-intercepts occur, and our x-intercepts all have a y value of 0. Okay, but this definitely is not a factor because that's remainder 4. This 4 is actually the y value in x equals 3. So there's a thing called synthetic substitution. If I wanted to know, like, okay, when x equals 3, what is y? Well, okay, well, if you subtract 3 on both sides, I could see if x minus 3 is a factor. If it goes evenly, the answer, if it goes evenly, that's a factor. I know it's an x-intercept. If it doesn't go evenly, literally the remainder is our function's y value. So that's what the next example is on the next page. It tells us, blah, 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 if a polynomial f of x is divided by x minus c, the remainder is the function value. So normally what we've been doing, so before this, we would straight up just plug in. So you don't have to write what I'm writing in blue. I'm just showing you. And I'm proving to you that we're going to get the same answer. So I'm going to do it the old-fashioned way, the way we've been doing it before, where you just plug in -2 into the equation, because I'm trying to find function value at 2. So I have 3 times, let's say -2 to the 4th, minus 8 times -2 third, plus 4 times -2 squared, plus blah, 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 blah. Oh my gosh, look at all this work. Okay, 3 times 2 to the 4th is 16. 48 plus 64 plus 16 minus 12 minus 9. Okay, 107. So much brain computation work, blah, blah, blah. Now let's just do synthetic substitution. This is the part that you should write. I'm going to write it in green. So if I put -2 here, and let me write the coefficients that are in front of all of my values, do a little synthetic substitution, our remainder should be 107. That is going to be the function value when x equals 2, -2. Bring it down, 3, multiply, add, multiply, add, multiply, add, multiply, add. No surprise, our remainder is 107. Literally what that means is f of -2 is 107. So, synthetic substitution, instead of just substituting straight into the function, you use synthetic division, and the remainder is the function value. There's a problem, just like this on your quiz. You use synthetic substitution to find the value. When I ask you that question, do not give me the quotient. Give me the value of the function. Coolio. Yes?
Wait, so you first plug in 2 and then...
So this is what the work should be. The part in blue was me proving that this is actually the function value. Hello. Awesome. So this right side is actually showing us what synthetic substitution is. But I showed you normally we substitute straight in and we see the function value, but on the right side, this is a much easier way. Because imagine if we had we did right here. Because
you just use -2.
Yeah, I just use -2. Because if I set x equal to -2 and I set that equal to 0, this is the same thing as the factor of x plus 2. So effectively, we divided this whole function by x plus 2. And since it doesn't go evenly, we have a remainder, it's not actually a factor. Cool. Okay, so that's how you do synthetic substitution. So similarly, literally what I just said, we found the function value for -2. If I wanted to know if x plus 2 is a factor, we're doing the same thing, synthetic substitution. So the next thing is I could ask you, is x minus 5 a factor of this function? So Cami, what do I have to do to see if it's a factor?
Just divide.
Yeah, so we do synthetic division. We just put 5 right here. And you always want to double check before you write down the coefficients if there's one missing. It's really the only way I could trick you. So write down all the coefficients and then just go through the quick method. So bring down the 1, multiply, add, multiply, add, multiply. Oh my gosh, it goes evenly, so it's definitely a factor. No remainder.
Factor if it is.
Huh? If we had a remainder, it would not be a factor.
When it
Yeah, no remainder means it goes evenly. It is going to be a perfect factor. Yeah, so this one, yes, there's no remainder, so we're good. So all this said was determine if it is. On the quiz, I like want you to fully factor it. So always read the directions. Read the directions. What am I asking for? If I wanted you to fully factor it, I would write x minus 5 times, well, let's see, we had a third, so I want to start with a x to the second. It's always one less. Maybe I should have warned you they were coming in. I wasn't sure. So
You knew they were coming?
there was a chance. Because normally they go into Miss Case's class, but she was reviewing for a quiz, because it's mostly like potential parents for like freshmen, so they want to see like freshman classes. Then she asked Miss Rotter, who teaches like 10th grade, but she's also like reviewing for a quiz. So I said, hey, like, this is a good class, and we figured you're always on task. So, yeah.
Imagine they walked in and you were talking about the homeless man outside your window.
Yeah, that would have been great. Okay.
Like 40 people coming in with the, I heard it outside the hallway. There must be 40 people coming in.
Oops. Okay. Yeah. If the problem wanted you to fully factor it out, this is what you do. You know how to factor x squared plus 3x plus 2. I believe in your ability. Okay. Also, don't forget Alex is due Friday, which is tomorrow. The knowledge check. Make sure you got that knowledge check done. This next example takes 2 minutes. Other reminders I have to tell you. Opening up at 8 a.m. tomorrow is the new Alex week, which is 5 topics. What? I know. Alex is normally due at 8 a.m. and then next week always opens at 8 a.m. on Friday and goes till the next 8 a.m. So theoretically, well, so the issue is lazy is not the right word. I was not lazy. Literally, I've been so productive. I've done so much stuff. I made your quizzes for next week and the solutions. Okay. I had your knowledge check. I forgot to change it, so it's due like 11 p.m. tomorrow or whatever. Don't do it before Shabbat starts. Do it before Shabbat starts. Okay? Okay.
I already did it.
If you've done it, then perfect. These are the ones I'm going to start and say, hey, if there are missing terms, use 0, star. You know what I'm talking about? When I say use 0, if there's a missing term, gotta put 0 in for placeholder. Okay. Do we really need to do the second problem? Is x plus 2 a factor?
Yeah.
Oh, proof. Okay. Blessed. Okay, we'll be done.